Welcome to a scientific exploration of how artificial intelligence can engineer your habits using reinforcement principles rather than willpower. This is the fundamental habit loop. A cue triggers a routine which produces a reward. Today we'll see how I can hack this system. Let's start with the brain science behind why habits form in the first place. The basal ganglia is your brain's habit center. It stores automatic behaviors to save cognitive energy for complex decisions. Research shows habits become automatic over time. Maximum effort is required on day 1, but after 66 days on average, the behavior requires minimal conscious thought. Here's the problem. Willpower is like a battery that depletes throughout the day. By evening, you have minimal willpower left for good habits. So let's ask, why does willpower consistently fail for building lasting habits? Willpower requires continuous energy expenditure. Each decision, each resistance to temptation drains your mental battery. This graph shows willpower declining throughout the day. Notice the steep drop-off after each decision point, represented by these yellow markers. Now let's explore how reinforcement learning provides a better framework than willpower. Reinforcement learning works through this cycle. Observe a state, take an action, receive a reward, which then influences future behavior. Notice the feedback loop. The three key components of reinforcement learning are the policy, which decides actions, the value function, which estimates long-term reward, and the model, which predicts outcomes. Unlike willpower, which depletes, reinforcement learning shows an upward learning curve. Each small success makes the next one easier, creating momentum. Now let's see how I can identify the triggers that activate your habits. AI analyzes 4 key categories of cues: time of day, physical location, emotional state, and social context. It finds patterns you might never notice consciously. This represents raw behavioral data. AI algorithms scan through noise to find the consistent pattern, marked here in red, that predicts when you'll perform a behavior. Let's work through a concrete example of AI detecting a coffee shop habit cue. Imagine you pass this coffee shop every morning at 8:30. Your phone's GPS logs this location repeatedly at this specific time. Out of 15 passes by the coffee shop, shown in yellow, you made purchases 4 times, shown in red. The AI detects this 27% conversion rate. The AI correlates additional factors. Tired mornings have higher purchase rates, shown by these red dots representing purchases that cluster on specific days. Traditional habits often have delayed rewards. I can engineer immediate satisfaction. This timeline shows the problem. There's often a significant delay between performing a healthy behavior and experiencing its natural reward. Take exercise. The natural rewards like weight loss and improved health appear weeks or months later, far too delayed for effective reinforcement. I can insert immediate artificial rewards. Points appear instantly, streaks update in real time, creating immediate, positive feedback your brain craves. Let's calculate the mathematical difference between immediate and delayed rewards. This shows temporal discounting. Rewards lose psychological value over time according to an exponential decay function. The mathematical formula is value equals reward divided by 1 plus k times delay, where k is the discount rate. With typical human discount rates, an immediate reward retains 100% value, while the same reward delayed by 30 days drops to just 17% of its motivational power. Let's explore how gamification creates the immediate rewards that drive behavior. Gamification elements like point systems and progress bars provide continuous visual feedback. Each workout adds to your visible progress, creating immediate satisfaction. Streaks are particularly powerful. 7 consecutive days shown in green creates loss aversion. Breaking the streak, marked in red, feels like losing something valuable. This shows engagement patterns with gamification. Notice the upward trend with periodic spikes at milestone achievements, marked by pink dots, which provide extra motivation bursts. The most powerful reinforcement comes from variable, unpredictable rewards. Variable ratio schedules, where rewards appear unpredictably, create the strongest behavioral responses. You can't predict which action will produce the reward. Comparing reward schedules. Fixed schedules shown in blue produce moderate engagement, variable schedules in green produce highest engagement, while purely random yellow schedules are less effective. Why do variable rewards create such strong behavioral patterns? Variable rewards trigger dopamine release during the anticipation phase, not just upon receiving the reward. This anticipatory response is what creates addictive engagement patterns. This shows dopamine release patterns with variable rewards. Each bar represents unpredictable spikes that maintain high engagement and motivation levels. Let's explore how I can help design tiny habits that require minimal activation energy. Reducing the habit to its tiniest version dramatically increases completion rates. Notice how activation energy decreases. In conclusion, I can significantly enhance habit formation by understanding our brain's habit loop, leveraging reinforcement learning, and using variable rewards.